Alright guys, we're going to go ahead and get started on our next project here, and this is going to be a job for a viewer of mine named Joseph who resides out in Nevada. And recently he purchased one of these PeWe Tools Multifix type tool post right here. This is the 40 position tool post. This is the same style of tool post that you see me use on both my Victor and Monarch lathes. Alright, this is just a different size right here. This is a size E from PeWe Tools. So Joseph had emailed me back whenever he was making this purchase and asked me if I could help him with this project. What he wants is a new T-nut made. This is the compound off of his lathe right here. This is the factory T-nut, but he didn't want to use this right here. He wanted to make a new one, and so he asked if I would make a new T-nut to fit the compound good, you know, and then we got to make the stem that goes down through the center of the tool post as well. So that's what this job is about right there. And whenever he had emailed me about it, I was pretty intrigued, and I thought this would probably be a good project for the channel. It would also give me a chance to actually see one of Peter's tool posts here in person, because I have never actually seen one of his. All I've got is my my Multifix, the original Multifix. So this is a good look at what they look like when you buy them new from PeWe Tools. So that's Peter Went, and Peter is the best source that I have ever seen or known about when it comes to the original style Multifix tool post. He knows every detail there is to know about these tool posts, about the original inventors, all of the different companies that have been involved making these, where they come from, all the tolerances, sizing, everything. So he has every one of these made to the exact tolerances of the original Multifix tool post. Every piece and component about this is manufactured the same way. And then once he gets them in his hand, he actually inspects them to the original fixtures for the Multifix tool to ensure that all the parts work, not only the tool post. You got your holders as well. Now I don't have it, he didn't send any of the holders that came with this, so I'm just showing mine in an example. But just looking at it, it seems to be excellent. Let's we're going to take the top plate off right here. We've also got this piece. This will have to be modified right there. There's the pointer. We'll talk about that in a second. So this piece right here looks exactly like the Multifix top plate. This has your 40 positions on there. All right, you got your clamshells right there. Looks like the handle is the same size that I use on mine. All right, and then you got your center right there, which looks like a big spline shaft. And this is the base and the top. So it looks good. You know, obviously I'm not sitting here checking it for hardness or tolerances on how everything fit up, but he ensures that every component, every part is the same as the original Multifix, and he guarantees that. So Peter, or PeWe Tools, is a good source if you're interested in any of this tool post right there. He has a wide range of sizes. He actually has sizes that were not originally available from Multifix. The smallest size that he has, and I haven't seen it up close, but it's probably about that big, is a AAA size. So he has AAA, AA, A, B, C, D, and E, I believe. And he's got some massive ones as well. So if you're interested in these, this is a good place to buy from, PeWe Tools. And not only that, if you need parts for yours, he'll sell you the parts, whatever you need. This is an example of some of the parts. See these 3 square-headed set screws here that go with the Multifix, and you see mine says made in Switzerland. Mine's the original. I needed some more of these screws, so he sent me those. This piece right here, the height adjustment, and the locking nut right there. And this is actually that piece here, is the bracket, the screws, the height adjustment screw, and then the locking nut right there. So all these parts are the same as the Multifix. So good quality stuff. If you need any of the components, you can buy them from him. All right. And saying that, this is not a sponsored video, by the way. I'm just showing you guys a good quality tool post you know, because these have become pretty popular and sought after, and I think Peter does a good job of replicating the original style multifix. All right, so what we need to do, I'm going to put this piece back together. This is going to be bored to 14 millimeter, and this is going to go down like this. All right, that sits right in there. So this will be 14 millimeter bore. This is the nut that Joseph provided. It's a 14 by 1.5 flange nut that will pull everything down like so. All right, and then so this is the pointer right here, and this fits on to the tool post. And then this is a spring. Once you get this on there, this is the spring right there that you snap into place. There's a little groove right there. And so the spring just holds the pointer in place. All right. And when you're using these tool posts, the idea behind this is that you have 40 different positions indicated right there. And so what you can do is you can have this thing set up, say, for 0 position for all of your normal, everyday turning, facing, whatever. All right, say you want to move it, you want to rotate this around 90 degrees. Well, you just go 10 positions. Since there's 40 positions, you divide that into 360 degrees. Every position is 9 degrees. So if you rotate this around to 10 positions, that's exactly 90 degrees. All right, so that's a good example of how that's used. You can have multiple tools set up and know exactly where, what position you might want to rotate this on to line it up. All right, I've actually never used that feature, but it is a very cool, unique feature built into the multifix style. All right, so now that we've got that covered, I wanted to kind of mention all that stuff. We are going to machine a brand new T-nut for this compound, and the way that Peter and Multifix recommends that you make a T-nut for your lathe is that you see this one was made that way. You've got the 2 set screws in there. So once you install the T-nut into your compound, you actually tighten the set screws, which pulls it up tight. And you have, when you make this, you have it a little bit taller than the face of your compound there. And then the way Peter recommends is that you go to a surface grinder and grind this so that the T-nut is even with the top. I don't have a surface grinder to grind this, so my plan is to probably just use the K&T mill. We'll set this up in the mill vise. There's not a whole lot of difference between this face and this face, but I think as long as we get this square and just touch off, we can deck this just enough to clean everything up nice and even. We'll just use a big face mill and make one pass across it and be done. All right. The other feature built into the multifix, you see these got these 3 holes here. Those are a 6 millimeter hole for this little dowel pin here, and you utilize that. So on your tool post, the T-nut, you would have a hole drilled. It's like so, and when you put this on there, this pin is lined up with that dowel, and that prevents any kind of rotating motion with this tool post. One of the holders that goes with this that you can use is there's a tool that takes a sleeve where you can use Morse tape or drill bits. And so if you're using the Morse tape or drill bit and you're applying a lot of pressure, this could rotate and move a little bit. So that pin actually keeps the tool post from rotating around while you're using it. Not only for drill, but if you're using some kind of heavy turning tool, it locks that in and keeps it from moving. All right, so we know we got to make the T-nut. We're going to make that. We'll machine a 3/4 10 thread down the center of it. And what I'm going to do is I'm going to make the stem. I've got all my drawings right here. The center bolt, should I say. This is what it's going to kind of look like. That's not drawn to scale, but I've taken all my measurements, and this is how it's going to look right here once I machine it. So you've got this counter bore right there. And so what I'll do is I'll have it threaded down into the T-nut. It's going to be turned so that it fits this area right here very, very close. And in the center of it right there, we've got it at 20 millimeters to fit up through there. And of course on the top, we'll have our 14 millimeter bore coming through this piece, threaded for the flange nut right there. And the other thing I'm going to do is go ahead and machine some wrench flats on the largest diameter, which is 30 millimeter. So that you'll be able to take a wrench, just a standard wrench, and tighten it into the T-nut there. All right, And materials, I've got this piece of 4140 that we'll use for the center bolt. All right, that'll take care of that. And then for the T-nut itself, closest thing I've got on hand is this 1x3 hot roll flat bar. So I'll just cut a piece of this off in the bandsaw, and we'll go to the K&T mill and we'll do all of our milling over there, get this down to the size that we need, and then we'll use the do-all mill to do our holes there. All right, so let's go ahead and get started on it. All right, we got our block of steel cut off in the bandsaw there, dressed just a little bit on the edges and get some of the rust off. So we'll go ahead and get that thing milled down to size. This will be our first cuts after we got the knee feed motor wired up correctly. Let's try, that's a 1/4 inch depth of cut, 10 inches a minute for our feed. Let's see what that does. Looks like it handled it better than it did before. Yeah, I think it did just fine. All right, well, we got a total of 1.25 inches to take off the width of this. I'll take another cut here and we'll flip it over and go ahead and mill it to our 1 3/4 width. Did even better. I went ahead and sped it up another 50 or so RPM. Looking good. We're doing a cleanup pass the other way there. Drop the feed rate down to 5 inches a minute. Just try to get a little better finish on it. All right, we're gonna stick it in here and go ahead and deck the top and the bottom just to clean that up, and then we'll leave enough there that we can finish it on the compound once we're done. This is the new set of 8-inch parallels I bought from KBC. We also got a nice parallel separator there too. I think I'm gonna probably go 2-inch. Nice looking grinding. Exactly what I wanted. Some 8-inch wide parallels in a nice standard size set. Alright, and I got the parallel separator too from them. And this one is made by Automatic Products, made in USA. Alright, perfect. Our width here, I was going for 1.25 inches. See what we got. More to the brown and sharp, we've got at about a thou under, 1.249. 249 and a half, so we got our size there. Only thing left we got to do, I was saving it for the end. I'll put a bigger end mill in there and we'll side cut the ends and get rid of that saw cut. That's an 1/8 of an inch depth of cut there. Doing good. All right, there's our T-nut finished out, minus the holes. That's the next step there. But we got all the ends filed, dressed, and there we go. I've actually got it milled to the same width of the compound here, so it's the exactly the same. Should be flush on both sides there. All right. Well, the next up, we'll go to the do-all. We'll go ahead and get our holes put in there, and then that will finish up the T-nut. Once we do that, get the holes tapped, drilled, and then we'll get to our center stem piece after that. We got our T-nut set up over here in the do-all so we can put our holes in it. So here's what the map looks like. We've got our center hole that we'll drill for 3/4 10. These two holes here are just going to be drilled for 1/4 20. And then here, this is our 6mm pin that I actually measured the bottom of the tool post, the center bore, and then the hole pattern. There's 3 holes in there. And I'm sure the nominal is a 50mm bolt circle where these pins are, but the actual measurement from the center to the center is going to be 24.4 millimeters. So that's where I'm going to drill that 6mm hole for the pin to go in, and that should line up perfectly right there. So we're just going to go ahead and we're just going to get the holes drilled here, and then I want to go to the flex arm to use that for tapping. I haven't used it for any small tapping yet, and so we'll just go over and do that. I can tap it right here, but I want to go over and use the flex arm and use that machine that I've invested in here. We'll do our center hole first, and then we'll move over and do our metric 6mm hole, and then we'll just drill the ends. Since the ends are evenly spaced from the end of the block, symmetrical, we'll just drill one and flip it around against our stop. All right, using our DRO, we are stepped over exactly 24.4 millimeter, or let's see what we got here, 24.4 or 960 thousandths. It's the same, the same, only different, right? All right, so what we'll do, this is our pin we're going to use, so we don't want it to go all the way through there. Let's measure it. It looks like it's going to be roughly 20 millimeters. So let's just take half of that. We got a DRO in our quill here. I've already got it set to metric, so we'll just, once we touch off and get a radius established, we'll go down 10 millimeters using that right there. Okay. And I've got some metric drills. I don't have a 6mm reamer. I'm going to use a 5.5 millimeter drill to drill the hole, and then we're going to just kind of like ream it with a 6mm drill bit right there. All right. We'll use the center drill on this one just to make sure that we maintain our exact center line. Just use the tip there. All right, we'll go ahead and put our 5.5 mil drill in there. What I'm going to do is I'm going to come down and touch it. Just kind of get it right about there, and then I'll stop the mill. We're going to bring it down here, touch it. I'm going to zero this quill out right there. That way I know I got a good 10 millimeter depth. right, there's our 10mm depth. We'll put our 6mm drill in there. Put a little drop of oil in the hole, and let's just kind of ream it to size with the drill bit. Careful not to drill the bottom because it'll make it kind of walk off a little bit. And let's see how we did. Look at that. See that? Just like it was reamed. Let me move this drill bit before I stab my finger. I'm glad that it didn't make me look like a fool on video here. See? Very close fit. That's a little trick that I've used many times if I don't have a reamer and I just need to get something done right away. Just drill it one size under, even if you got to mix, you know, imperial wire sizes with a metric. Just drill it slightly small and then use a good drill bit that you know has got a perfect grind on it to drill it right to the size that you want right there. So that's great. Perfect. Just going to touch off on this edge, and we're going to move in a ½ inch from the end of the part there. So let's see, 3/4 on the dial up here. Go ahead and get these holes drilled. These are going to be for 1/4 set screws. Just make our divot there, and then we'll get the hole drilled. We'll be using a number 7 drill bit, tap size for our 1/4. Now that we got that one drilled, since it's going to be the same as this end, we've got it on our stop, so we'll just simply flip it around like so, and that whole location will line up nicely. And those red marks were just references with a scale. They're not exactly on the center there. Pretty darn close though. Getting that center hole chamfered nicely too, so we don't have any burrs hanging out of it when we tap it. All right, we've got our flex arm ready. We're going to use it to tap our 3 holes. We've got it adjusted for the 3/4 tap. So these are the 2 taps we'll be using right here. We're going to use a 3/4 10 for the center hole, and we've got a 1/4 20 for the 2 set screw holes. So this is the smallest tap that's rated for the GHM 60. I've had a lot of folks ask about how to adjust the torque on these things. FlexArm actually builds these tool holders right here, and they are adjusted from their factory to provide the right amount of torque for these taps. So like if you was to use this to bottom tap, or you hit the bottom, this thing would actually clutch out and not break the tap. So this is how you this is how the torque adjustment works on them. They're built into the tool holders. So we'll go ahead and start with the 3/4 first to get it done. Go ahead and speed it up some. Just get it centered up on the hole there. Get a little cutting oil going. Just watching the bottom there. Reverse it out. There we go. I probably could have done that a lot faster. I just got it in gear 1 right now. So that looks good. Perfect. All right, so we're going to take this one out. And we'll go ahead and stick in our little bitty quarter 20. All right, and we'll reset the speed, and we'll go ahead and tap our quarter 20 now. All right, so here we go with our quarter 20. Hopefully we won't have any catastrophes. And by the way, the tap isn't going to go all the way through, so I'm going to tap it as far as I can and then back out. And then after we deck this thing off, I'll run a hand tap down through there to make sure that it's tapped all the way through. All right, I'm going to put a little drop of oil right there in the hole. Send it up. All right, I'm going to back her out. We'll come over to our second hole and do this. Nice. All right, there we go. 3/4 20 tap holes. So here is the big boy 2-inch tap right here, and FlexArm actually give me this right here as just a gift, so that we can make a little show and tell here on with the FlexArm. But just to show you an example, there's a 2-inch. This is the maximum capacity of the FlexArm that I have, and then there's the quarter. So quite a size difference right there. So whenever I get a chance, I'll take a block of steel and we'll drill a proper tap size hole in it. We'll come over here and we'll test it out with the big 2-inch tap. I actually realized after I had told you that we would tap this after we deck it off, I remembered that, well, I got to have the tapped holes all the way through, because we're going to be locking this thing down using these set screws to hold it in place for the permanent position where it's going to be inside the compound there. So I got a good bottom tap here. We're going to go ahead and run this through there, and I think I got just enough to clean that hole up. It just broke through. We got just enough. I got about 1.5 or a half rotation out of the hole there, so we did good. Just enough length. And then I'll we'll get these tapped. I got to go find some set screws. I'll see if I got some longer set screws we can use to install in this. We'll get these, and then so our next phase is to go back to the K&T. There we go, hitting the bottom, and just broke through right there. All right, and then so we'll set it up in the mill vise in the K&T, and we'll make our nice little deck cut across here to make this surface nice and even with the top of the compound there. All right, there's our compound. You guys, I don't think you've seen it fit yet. Maybe I showed you earlier, I can't remember now. So there we go. Got just a little bit of wiggle room there. So we're just going to center it up on the ends. And these are 3/4 length set screws. Tighten them in just like that. And so you can see the amount that we've got to deck off there. It's actually a little more than I thought it was. And this is where it'll live, right there. This is going to shorten the depth of my hole. That's one thing that I did overlook, but I don't think that's going to be an issue there. We're still going to be able to use that pin just right there where it's at. All right, to the mill we go. Before we go to the mill, I was going to do this. I thought I would just show you. We're using our precision ground stones, and we're doing this just to clean the surface, get any dust or dirt off of it. Just doing this to make sure there was no burrs from handling it, shipping it around. I want to do the bottom because we're hoping that the bottom is parallel with the top. We'll go ahead and do the side here as well, just to make sure there's no burr on the side. I felt one right in there, but we got it off. This side as well. I felt a couple little ones in there. There we go. All right. All right, guys, we're all set up in the K&T, ready to make our cut. And I opted we're going to use the Y-axis to cut this, and all that did was just eliminate me having to loosen the vise and turn it around and then re-indicate it. So I've got just enough room. We're going to be cutting from the back and feeding that way. I've got the vise all the way over against the ways right there. So we got just enough clearance there to start our cut, and they'll be able to bring the part all the way out from underneath the face mill there. So on the back side here, I have just touched the tool there. It is just touching it. That's going to be our 0 point right there, but we'll probably take another, say, 2 thousandths past that. I did mic this to see how parallel it was, and I had 1 thousandths discrepancy in that. So that's probably why we're seeing the tool touching more on this side than it is over here. So we'll go ahead and deck the bulk of that off there in one pass, and then we'll come back and feed it up. The total of 12 thousandths, and then hopefully make our cleanup cut across this right here and be done with it. See what it does on the back end there. I've got the vertical head here trimmed as close as I can, and it looks like we got a good finish. I swapped all those inserts out because we had some those have been on there for a long time, and the corners were starting to get burned up. All right, that's looking good. Let me turn that off there. Finish is looking really good on that. I'll tell you what, I know that I can just clear this and stop the feed, so I think I'll just go ahead and we'll just feed it right here, and I'll watch it come across. I changed my mind. We're going to go ahead and feed it the way I did. That way when we come out, we can see our finished cut there. So we are ready to go. Well, that's what we were looking for. Got one clean cut all the way across there. I was trying not to get into this part of the surface right there, which it wasn't very much. You can just barely feel a step there. Got you back over here on the bench. We're going to use a flex arm. We've got a drill chuck and a chamfering tool. We're going to go ahead and re-chamfer these holes here. A little bit more there. How about that? Yep, that'll work there. We'll get the quarter holes. Just got to get it lined up. It's a small hole there to line up on. Okay, there we go. Now, pinhole, I'm going to do that by hand with a Noga tool. A little bit more. There we go. It's got some chips down in there, but all right, let me grab the tool post. And it will sit on there just like that. Looks like our center hole lines up perfectly there. All right. All right, well, our T-nut is complete now. So we can go ahead and move on to our next phase, which is going to be the center bolt here. We'll use this piece of 4140 to machine that out of. That'll screw in right there, and then that tool post will sit down on top of that. So it'll all be lathe work there. But this turned out good. It did exactly what I was hoping that it would do. And we got our pin there, and there we go. So we've got a nice seat across the whole bottom of this Multifix style tool post right there. That's what Peter told me this thing was designed. You need to have it, this needs to be designed and machined so that the entire bottom of this is sitting on the compound there, not just on the two sides of the top slide. So I think we met our goal there. All right, so next up is the center bolt. We'll meet you down there at the lathe, okay?